Welcome everyone. In the last lesson, we talked about cold chain logistics. Now let's review it before we move on to the next lesson. First, what is cold chain logistics? It's a system used to manage the storage and transportation of perishable goods that need to be kept at specific temperatures from production to consumption. This includes food, pharmaceuticals, and certain chemicals. The main purpose of cold chain logistics is to ensure that these temperature-sensitive products remain safe and of high quality until they reach the consumer. Cold chain logistics is complex due to varied temperature requirements. Ice cream needs much colder storage than apples, making management challenging. Any break in the cold chain can lead to significant quality loss. Coordination is crucial. Multiple stages and handoffs from initial processing to final distribution require precise coordination to maintain the right temperature. Imagine passing a delicate glass of water down a line. Everyone needs to handle it carefully to avoid spilling. Similarly, all parties in the cold chain must work together seamlessly to maintain product integrity. Cold chain logistics is costly. Investment in refrigeration equipment, insulated storage facilities, and specialized vehicles is substantial. Energy costs are high, as cold storage warehouses and refrigerated vehicles use a lot of electricity and fuel. Despite these costs, the benefits of reducing spoilage and ensuring product safety make cold chain logistics a crucial investment. In summary, cold chain logistics is essential for maintaining the quality and safety of perishable goods. Its complexity arises from the varied temperature needs of different products and the need for precise coordination at every stage. While it is a high-cost system, the value it provides in preserving product integrity is invaluable. In cold chain logistics, there are three main parts: cold processing, cold storage, and cold transportation and distribution. Let's start with cold processing. Cold processing is all about the immediate cooling and freezing of perishable products right after they are harvested or produced. The goal here is to lock in freshness, maintain quality, and extend the shelf life of these products. By quickly reducing the temperature, we can slow down the growth of microorganisms and enzymatic activities that cause spoilage. First up, we have the cooling and freezing of meat and seafood. Right after harvest or slaughter, these products need to be rapidly cooled to around 0 to 4 degrees Celsius within a few hours. This prevents bacterial growth and helps maintain their quality. For example, fresh fish can last up to 10 days at 0 degrees Celsius, but only 1 to 2 days at higher temperatures. Following this initial cooling, quick freezing at -18 degrees Celsius or lower can extend the shelf life of seafood to several months, often up to 6 months or more depending on the specific type of seafood. Next, we have the pre-cooling of fruits and vegetables. This process removes the field heat from freshly harvested produce, helping to slow down respiration and delay spoilage. For instance, leafy greens should be cooled to just above 0 degrees Celsius, ideally around 0–1 degrees Celsius, within a few hours of harvest. This rapid cooling can extend their shelf life from a few days to about 2 weeks. Other fruits like apples should be pre-cooled to around 0–4 degrees Celsius, which can extend their shelf life to several months, often 3–6 months. Finally, there's the low-temperature processing of dairy products like milk and cheese. Milk, for example, should be cooled to below 4 degrees Celsius immediately after milking, typically within 2 hours, to ensure it remains safe and fresh for consumption. This can keep milk fresh for up to 2 weeks under proper refrigeration. Cheese often undergoes aging at around 10–12 degrees Celsius, but must be kept at lower temperatures around 0–4 degrees Celsius during storage to prolong its shelf life, sometimes up to several months depending on the type of cheese. To achieve these processes, we use various types of refrigerating machinery to bring down the temperature quickly and efficiently. Additionally, we have quick freezing machinery designed to freeze products rapidly. This ensures that ice crystals formed are small and do not damage the cell structure of the food. Proper design for energy efficiency is crucial. By designing our refrigeration systems to be energy efficient, we can reduce operational costs and minimize our environmental impact. Effective management practices are also key. This includes regular maintenance of equipment, monitoring temperature levels, and training staff on best practices. Cold processing does come with its challenges. Some common issues include maintaining consistent temperatures, preventing cross-contamination, and managing energy consumption. To address these, we can use advanced monitoring systems, implement strict hygiene protocols, and optimize energy use through efficient design and operation. Let's look at a real-life example. Imagine a seafood processing facility that uses quick freezing techniques to freeze fish immediately after they're caught, dropping the temperature to -18 degrees Celsius. This ensures the product remains fresh and of high quality, extending its shelf life to several months when it reaches the consumer. Now, let's dive into the second part of our lecture today, focusing on cold storage. Cold storage is the practice of storing perishable goods at low temperatures to preserve their quality and extend their shelf life. This is crucial for maintaining the freshness, safety, and nutritional value of products like fruits, vegetables, dairy, and meat. Cold storage involves keeping products at specific low temperatures to slow down the biological processes that cause spoilage. This is especially important for products that are sensitive to temperature fluctuations. By storing these goods at low temperatures, we can significantly extend their shelf life and reduce spoilage. There are different types of cold storage facilities. Refrigerated warehouses are one common type, where products are stored in large, temperature-controlled environments. These warehouses can be set to different temperatures depending on the type of product being stored. For example, fruits and vegetables are often stored just above 0 degrees Celsius to prevent freezing while still slowing down spoilage. Controlled atmosphere storage is another type, used mainly for fruits and vegetables. This involves controlling not just the temperature, but also the levels of oxygen, carbon dioxide, and humidity to further extend the shelf life of the products. Design and management of these storage facilities are critical. Proper design for energy efficiency helps reduce operational costs and minimize environmental impact. For instance, using insulated panels and efficient refrigeration systems can significantly cut down on energy usage. Management practices also play a key role. Regular maintenance of equipment, continuous monitoring of temperature and humidity levels, and staff training are all essential to ensure optimal storage conditions. Cold storage comes with its own set of challenges. Maintaining consistent temperatures throughout the storage facility can be difficult, especially in large warehouses. Any fluctuation can lead to significant quality loss. Additionally, energy consumption is a major concern due to the need for continuous refrigeration. Solutions to these challenges include the use of advanced monitoring systems that provide real-time data on temperature and humidity, and implementing strict protocols to prevent cross-contamination. Let's consider some real-life examples of effective cold storage practices. For instance, an apple storage facility might use controlled atmosphere storage to keep apples fresh for several months. By maintaining a low temperature around 1 degrees Celsius and controlling the levels of oxygen and carbon dioxide, the facility can significantly extend the apple's shelf life without compromising their quality. To wrap up our session today, we've covered two crucial parts of cold chain logistics: cold processing and cold storage. In the first part, we discussed cold processing. We learned how immediate cooling and freezing of perishable products right after harvest or production help lock in freshness, maintain quality, and extend shelf life. We explored specific processes like cooling and freezing meat and seafood, pre-cooling fruits and vegetables, and low-temperature processing of dairy products. In the second part, we delved into cold storage. We defined cold storage as the practice of storing perishable goods at low temperatures to preserve their quality and extend their shelf life. Understanding these fundamentals is essential for anyone involved in cold chain logistics. In the next lesson, we will look at the third part in cold chain logistics structure, cold transportation, and distribution. See you in the next lesson.